started, and if anyone else comes in, then that's fair enough.
Close the door.
Yeah, close the door, and then people can sneak in if they want to. That's not a problem. Hi, good afternoon, everybody. My name's Jonathan Gallimore. I work for Tomitribe. I'm one of the software engineers there. And I'm also a committer on the Apache TomEE project. I've been doing that for about 10 years now. So if you haven't come across TomEE before, it's basically a Tomcat server which we open up and add in the various Java EE components, and we do the integration between all of those components, zip it back up and run it through the certification process. More recently, we've been adding the various different MicroProfile specifications into TomEE. So what I want to show you today is how you can secure microservices. I'll show them running in TomEE, but I'll show you how you can secure those using MicroProfile JWT. This is something that we've been working with a few of our customers with for a couple of years now. So we've been helping them move their microservices onto our platform. And they sort of say, how do we secure this? And going basic auth is not such a great answer anymore. So what I'll do is I'll take we'll have a quick look at basic auth, and I'll do a run through of OAuth 2 very quickly. I'll introduce JWT and how that works. But what I'll do is also show that in the context of an architecture for your application, so that you can see the effect that making these changes to your security model actually affect the architecture of the application. And then at the end, I'll do a short demonstration so you can actually see a working application with MicroProfile JWT. And we'll see the journey that the token goes on, and then I'll show you the code for the application as well, so you can see what you need to do in order to enable MicroProfile JWT inside your own application. So this is the baseline architecture that I'll use for this talk. So what we have on the left-hand side here is we've got 1,000 users with their devices, and they're each doing 3 transactions per second on their device. So kind of at the front end of the application, we've got 3,000 TPS coming in, and then we're making an assumption that for each one of the calls from their device, we're going to call 4 different microservices on the back end. So if you're familiar with basic authentication, this is what a message looks like. So we have the authorization header in the middle here with the basic scheme, and then we have this super secure thing here, which is where we're encrypting the username and password. I'm joking, of course. This is just base64 encoded. So if you're able to intercept this, you effectively are able to decode the user's username and password. So if we look at how this works in our architecture, effectively we have our 3,000 requests per second coming in, and we need to authenticate those requests. You need to look at that authorization header and see what's going on. So that might be, we might be using LDAP as our source for users for that, or we might be using a database, for example. So we're going to have 3,000 transactions going on at our LDAP system or our database system down here. And then on the back end, what do we do there? Possibly nothing at all, although this leaves us kind of wide open to someone being able to call these services directly. Or if we propagate our credentials through, then we potentially end up with this situation where we've actually got, a huge volume of requests coming through, where the back end is also checking the credentials that are being passed through to make sure that access is valid. Of course, if we've got a bad actor, someone who's trying to brute force username and password credentials, we potentially have even more requests that we have to validate down here. So basically, this is kind of a single point where everything's ending up in terms of validating our usernames and passwords. So we could look at OAuth 2 to solve this problem. And the theory behind it is that basically we replace the username and password that's being sent in every request with a token. And it's quite nice because we get a token for each of our devices. So if, for example, I'm using an application on my laptop, on my tablet, and on my phone, if one of those devices is stolen or lost, I can come into the application and revoke the token, and I don't completely lose my access. I'm just shutting off the token that's being used on that device. So if you're not familiar with OAuth 2, the process that this goes through is we take a username and password and we want to turn it into a token to start us off. And to do that, we go through this password grant process. So hopefully you can see it on the slide, but basically what we have is a form URL encoded post request with a username and a password and also a grant type. If this looks familiar, it's because this is pretty much every login form we've ever written in the last 20 years. The difference is what we get back. So we're getting back an access token and a refresh token in a small JSON payload. And on the back end of this, effectively what we're doing is verifying our password in LDAP. We're generating a token, and we're also taking all of the information about the user, so what roles they have, what their username is, and any other attributes, and we put it into a token store. So effectively our token is becoming like a primary key to a record that's in that token store. So in order to use the token and actually consume our services, the call is very similar to the basic authentication call. So we have bearer in the middle here, and then we just pass in our access token on the authorization header. And we can continue doing that until the token expires. So if you notice on here, you can see there's a small expires in. That gives us how long the token's going to last for. So we can keep using that token until it expires, at which point we'll get a 401. And then we can either go through the password grant process again, which will involve us remembering what the username and password is on the client side, or asking the user for those credentials again, which might be a little bit frustrating. Or we can use the refresh token grant, which is very similar to the password grant, but instead of passing username and password through, we pass through the refresh token that we received in the first call. And the refresh token typically has a much longer expiry time, so that might be days as opposed to minutes. And what we do on the back end is we check that that is a valid refresh token, find out who it belongs to and the roles associated with it, and then we generate a new access token, refresh token pair and return those to the client. So we have our old pair and our new pair, and then we're able to continue calling the service with the new access token. So what have we achieved here? We've basically replaced our username and password that's going over the wire with every request with a token. But crucially, that token is just a pointer to some state on the server. So if you think about it in HTTP terms, it's a bit like a HTTP session where you have a JSession ID going back and forth, and that's referencing your session on the web server. It's kind of the same thing. If we look at this in terms of our architecture, again, we have our 1,000 calls. So we're assuming on this diagram here that we're doing our password grant at the start of every day. Typically, your refresh token would last longer than that. But once we've done that, we're then getting our 3,000 TPS with our tokens on, and we have to go and then check those tokens against the token store. So we have 3,000 transactions per second going on here to check our access token. So our LDAP server's off the hook, but we've introduced more checks down here to a database. And then what about on the back end? Well, if we want to go and validate the token there, we also have to have each of the back-end microservices doing the same thing. So although we've shifted from the username and password, we still have the challenge that we've got this sort of single point of failure here, and we're hoping that that's not going to catch fire. Obviously, if we introduce our bad actor here that's trying to brute force tokens, again, all of those tokens have to be checked at the token store as well. So I'll talk a little bit about JSON Web Tokens now. So the key thing here is that this isn't mutually exclusive to OAuth 2, it's used in conjunction with OAuth 2, and it's actually quite a small, subtle change to OAuth 2, but it can have quite a big impact on your architecture. So it's pronounced JWT. I'm not sure why, because that's not how it's spelt. I don't know when a W started to sound like an O. But basically, it's a way of encoding the token. And so what we do is we create this fancy key value pair map of values, and those key value pairs are called claims. So we put those in a map, and it's in JSON format. And then we base64 encode that map, and then the token then gets digitally signed using an RSA private key. You can also use a HMAC key, but where that becomes a potential issue is that you can't really share that key around your architecture, whereas with the private key you can obviously distribute the public key everywhere that it's needed. There are some built-in claims. The specification requires that certain claims are there. So this would be things like who issued the token, when it's valid from, what point the token expires, who it's been issued to, and what roles they have, etc. But you can put in any other claims into the token that you wish. So any other state that you want the token to carry, you can add in there. And if you want to encrypt values as they are in the JWT, then you can do that as well. So previously our access token looked a little bit like this, and now it looks like this. So if you had to pick which one of those two, without knowing the structure of it, you'd probably be inclined to go for that one because it looks simpler and there's less stuff going over the wire, and this kind of looks a bit nasty. But if we unbase64 encode the three sections of this, so you'll see that there are two dot characters that separate the three parts of the token. So if we decode each of those, what we have here at the top is a header, and there are a small number of standard headers that go into this. So we've got the type of the token here, which is the JWT. We've got the algorithm that was used to sign it. Another parameter that might appear there is a key ID. So if you're using multiple keys, you probably want to give whatever's going to try and verify this token some sort of clue as to which key you use to sign the token. In this instance, we're just assuming that there's one key that's in use here. The middle part here in the yellow, hopefully you can see it okay at the back. This is our map of claims. So you can see the standard set of claims. We've got the ISS, which is the issuer. So this is who actually issued the token. So in this case, we've got the demo to superbiz.com. There's the EXP, which is just a timestamp. This is when the token expires. And so we expect anyone who's verifying this token to reject it if the current time is past that expiry timestamp. Similarly for IAT, that's the issued at timestamp. So it shouldn't be, the token is not valid before that particular time. And the JTI claim at the bottom there is that's a unique field. So you should ensure that's as unique as possible, and that's to prevent any kind of replay. Okay, so that would be what that would be used for. At the very bottom, this is the RSA signature. So using our private key, we take the other two parts and we create the signature from those and then append that to the end of the token. So, like I said before, this is a subtle change, but it can have a high impact. So what we had before is the client had a pointer to the token, and all of the state was held in the token store. What we have now is we create the token by pulling user information from LDAP or our other identity provider. We format that up into the key map of key value pairs. We sign it. We keep a pointer to it so that we can actually revoke the token. Okay, so we can actually do a check on the token and say, you know, has this been revoked? If so, reject it. But then we pass the whole thing back to the client, so that all of the state is held inside the token. So, and therefore, the client is effectively looking after that state for us. So we're keeping a lot less information on the server side. So effectively, we've reversed it. So the client's got the state, the server's got the pointer. And this is a bit more like, you know, where regular OAuth is like a HTTP session, this is a bit more like a HTTP cookie, where the information is held inside a cookie. So how does that look inside our architecture? So the first thing to note is that basically none of our calls have really changed. So in terms of the payload that comes in for our password grant, it's exactly the same. The payload that's returned from that is the same, but the access token is just much bigger. In the background, we're doing the different process where we're just keeping the pointer in the database, and token generation is different, but the actual interface as it is to the front end is exactly the same. In order to actually use the token, the process again is exactly the same. So we have the authorization header with the bearer scheme, but we're just using the JWT token. So the only thing that's really changing is the format of the token itself. So this has quite a big impact on our architecture, because the key thing that we're able to do is we're able to do the validation of the token in memory. It's just CPU and memory. We don't actually have to go off and actually talk to an IDP server or an LDAP server or a token store in order to check that these things are valid. We can just do it purely in CPU and memory. So we're able, for our 3,000 transactions per second that come in, we can do our signature validation right on the front end with the public key, and anything that fails that check, we just throw that straight in the bin. Go ahead.
And just how do you solve token revocations in this case?
So that's a great question. So you can do that at the access token point. We tend to do that using the refresh token. So we tend to have quite a short period of validity for the access token, and then we'll actually do the revocation check on the refresh token. So you know, if you revoke the refresh token, then the access token will expire shortly after. So you're not actually going off and checking that database every single time. Okay, but it's worth checking out what your particular supplier supports. Okay. But crucially, if someone's just trying to brute force you with tokens, you can, you know, before you even have to go and do that check, if you fail the signature validation, then you're not coming through. So you know, if you haven't got something that's signed with the correct private key, then you don't even get to this point. So even if you're checking on your access tokens, you know, if you've got your 6,000 bad tokens here, you know, someone's trying to spoof your tokens, your system here is not going to get hammered with those checks. Does that make sense? Hopefully it answers the question as well. Cool. Okay. And then on the back end, we're able to do the same validation. Okay, so each of these microservices can have the public key and can also do the same validation. So where we had the scenario at the start where we maybe weren't putting authentication on this, and you would be able to make a call to that web service with no authentication, Now, we know that we know where the call is coming from and that it's got a valid token. We also know who the original user for that call was as well. So if we're, so for example, Joe can't access a web service and try and get Barry's salary information because we know in the token that the username is Joe. Okay. So again, all of the token checks can happen in just memory and CPU at the back end. So anything that's failing a check there is not going to go off to our token store to hammer that. So who's familiar with MicroProfile in the room? Handful of people. Okay. So MicroProfile is a set of specifications. It lives at the Eclipse Foundation, and basically it's been going on for about 1.5 years, 2 years, and it's got the idea behind it is to provide something that's got quite a rapid release cadence. So the aim is to put out a release every quarter or so, and we started off with a fairly small set of specifications, so it was targeted at stuff that was already kind of existed really, but was fairly, a minimal number of specs to put together, a microservice. So CDI, JAX-RS, JSON-P, but it's grown to a much bigger set of specifications, and we're currently at MicroProfile 1.4 and 2.0. So we kind of have two version lines that are fairly aligned with Java EE. So 1.4 is slightly older and 2.0 is a little bit more bleeding edge. And the specifications that have been added, so configuration. So if you've ever had to manage configuration inside a web app, the config spec is well worth taking a look at because it provides a fairly standard way to do that that's well integrated with CDI. We've got fault tolerance, we've got the JWT spec, which is this one that we're looking at now. There's health checks and metrics, etc. And this is a list that's growing all the time, so we're expecting to see some reactive specifications being added to this in the near future. There's a large number of companies involved, and if you go to any Jakarta EE talks, you'll see quite an overlap with the vendors. It's a similar set of people that are working together on this. So it's highly collaborative. So if you join the list, you'll see all of these folks talking together, and there are regular calls for each of the specs that that representatives from the various different companies join as well in order to help move this forward. If you're wondering why, I don't know what things are going to be like with Jakarta EE, but typically the release cadence of Java EE has been relatively slow. So gone from EE 6, 7, and 8 has been they're kind of 3 or 4 years apart for those releases. So we're looking to enable folks to move quicker and to collaborate quicker. But also there's a large number of specs in Java EE. So we're aiming to be a smaller set that's very much more focused around building microservices. There's a number of different implementations. So I'm looking at TomEE because I'm a TomEE committer, but you'll probably see some familiar app servers to you by a number of different vendors there. So looking specifically at MicroProfile JWT, our most current version is 1.1.1. TomEE is currently at 1.0, and I'm working on the 1.1.1 implementation at the moment, but it's not quite ready. But basically, it's an easy way to do your role-based access control with the JWT. So the idea is that in terms of the validation side of things on the back end, that heavy lifting is done for you, and you can use the principles and get claim values in your code really easily. What it doesn't focus on is actually generating a token. So in the demo that I'll show you, we have our own access gateway that's actually generating the token. But inside the TomEE that's running the microservice, we're going to extract the token, we're going to identify the caller, and we're going to enforce any permissions on that token. So I'll just show you our little demo application here. So we've got a fairly simple sign-in screen. So if I log in, I've left the tab open here, so hopefully you can see my network traffic okay. It might be a little bit small for the guys at the back. But you can see here our call to the token endpoint to do our grant. So you can see the username and password and the grant type that have been passed through. And we've got our enormous, whoops, not quite sure how I managed that. We've got our enormous access token and refresh token response coming back. And then on subsequent calls inside the application, you can see that we're using the bearer scheme here on the authorization header to make our call. So, you know, as I showed on the slides, hopefully that makes sense. One great way, if you want to just inspect what's going on inside a JSON Web Token, there's a site called jot.io. If you come in here and paste your token, you can see everything that's going on here. So you can see the key that this was signed with. You can see that we're using RS256, and it's a jot token. And you can see all of the various different information that we've got about John in the token here. So we've got the standard claims that I mentioned. So the expiry timestamp and the issue date timestamp, and there should be the issuer as well up here, and our unique identifier. And then everything else that's in here has either come in from our authentication source, or it's a custom claim that we've mapped in when we've generated this token. And what you can bring in will really depend on what you're using to actually generate your JWT tokens with in the first place. So Tomitribe's own system will allow you to call any endpoint to bring in that information or look things up in a database, as well as bringing in attributes from LDAP. But the capabilities there will depend on what you're using to actually do your authentication. Okay, so let's take a look at some code. So this is a fairly standard REST application. So we're using Vue.js to actually create the front end that you see there, and that's just making REST calls to a JAX-RS application. So in order to actually set the application up to use JWT, you will need to extend this application class in JAX-RS and provide this login config auth method equals mp JWT here, and that will tell the server that you want to use the MicroProfile JWT way of authenticating your users. So that's kind of how you switch this on. Okay.
Can you switch it on from configuration, like because you might want to use JWT in production, but basically.
That's a good question. I'll follow up with you afterwards if that's okay, because I may need to come back to you on that one. But yeah, that's an excellent question. In terms of our actual resource, you'll be able to see that I've got a few different things that are being injected here, and this is all provided for you by the server. So there's an API jar that you'll need to include on your class path, so that you have things like the JSON Web Token class and the claim annotations available for you. But you don't actually need to do any more heavy lifting other than that. So you can get a JAX-RS security context injected, and this has methods on it, so you can go and say, is the user in this particular role, or go and get me the user's name, for example, and you can use that to verify what access they have. So in a couple of the methods here, you know, we're doing a manual check, you know, saying, you know, does this security context, you know, is the user in this role create? And if they're not, then we're going to send them a 403. This class here, JSON Web Token, extends from the standard sort of principal class. So you can inject this, and it's got the regular methods that you'd have on principal, but with some helper methods where you can say, get me this claim, or show me the list of claims that are available on this JSON Web Token. And then finally, you don't actually, you know, there's another way to get those claim values, so you don't actually have to go onto the JSON Web Token object if you don't want to. You can actually inject claims straight into your code like I am here. So for example, if I'm interested in the email address, I can say @inject @claim email, and then there's my field, and I can just pick that up at any point during my web service call. And then finally, if I come down to the bottom here, you can see that roles allowed is also supported with MicroProfile JWT. So in the same way that you might be used to with a Java EE application, securing those with roles allowed also works here. So if I flip back to here, you can see this user has a set of roles here. So they have the create role, but they won't actually be able to go and do a delete operation. So that should, oh, my access has expired. Thank you very much. I have a really short expiry time on my token. But if I try and do the delete, I get kicked out here. So, oh, I will just flip back to my code. Sorry, I've missed something. In order to configure this, there are a couple of things that you will need to tell the server about, and specifically that will be the set of issuers that are valid for the token, and also the public key to use to validate the token as well. So there's a change here from MicroProfile JWT 1.0 to 1.1. So this is now configured with the MicroProfile config. So you can actually specify these just with some system properties to make it easier. With 1.0, it wasn't really specified. So in TomEE, I have this .auth context info, which reads the public key and the issuer. And this is just a CDI producer, but this won't be needed with the MicroProfile JWT 1.1. So just very quickly, sort of looking to the future, it's likely that we'll see some additional claims coming along that'll be part of the standard. So most likely how to specify things like roles, I suspect will come along there. If you were a bit sharp-eyed and just looked at my code there, you'll notice that there was a grace period in the context info object that I was creating. So that's a tolerance on the expiration time of the token, and that's really to allow you to cope with there being a time shift between the server that's issuing your token and the one that's validating your token. So that might become part of the specification as we go forward. One of the other things that we're seeing is a lot of interest in actually pushing the JWT around as a cookie to enable things like single sign-on. There are likely some security things that will need to be ironed out as part of that, but I would expect that to be coming along as the specification evolves. And that's it. I'm happy to take any questions. All the slides are available at this URL here, along with our demo application and everything else, if you want to run through it. I'm around for the rest of the conference if you want to ask me any questions. I also have some T-shirts if anybody would like some. And also there are some events. There's tonight and tomorrow night. I have beer tickets. I can't possibly drink all this beer myself, so please do come and grab some beer tickets from me, and I'll hope to see you this evening. Does anybody have any questions now? Thank you.
And yes.
Would you pass on, if you would call a microservice with a JWT, would you pass on this JWT to another microservice? And is there support in the...
Yeah, so you'd effectively be propagating that authorization header right the way through. So if you've got one microservice calling another, you can pass the authorization header through.
Would that be automatic, or do you pull it out?
You would pull that out as it stands at the moment and pass it on. It can get quite interesting because where you're passing this thing on, you're obviously handing a service something that, you know, a token that can be used to come through the front door, and so you may see implementations where they actually wrap the token, so they sign it with one private key, which will let you actually come in through the gateway, and then sign it with another private key, which is and that's used to do the validation around the back, and then it gets, you know, this token is unwrapped by your gateway. So you're passing around a token to different services, and they could even be third-party services, but those services wouldn't then be able to make a call as the user. So it can get quite sophisticated. Yes, sir.
Annotate the application with login config. Does that mean that you cannot expose a public endpoint from that application? Like, it requires authentication for every single request?
So I think the answer to that is it depends. Let me check on that, and I will come back to you. But yeah, certainly that's how it's activated. But I would expect you to still be able to have some public endpoints in there. I know that I'm digging around in those TCK tests right at the moment, and so as I'm implementing 1.1, there are a few issues in that area. It's not very specific in the spec as it stands at the moment.
Because I have commented some things about the spec itself, but yeah, maybe one thing that you are using password flow, and like I do prefer the code flow because like here it requires you to actually enter the username password, and like the more secure approach would be to redirect you to a login page of a.
Yeah, sure.
Like just one thing that like I try to see the most secure.
Yeah, so you'd effectively like to see, you know, right, yeah, that's not valid. Go here to obtain your new token, and then come back. Cool. Any other questions?
Do you know if there's any provider that supports the MicroProfile claims? Because there are now two claims, UPN groups in the MicroProfile spec.
I'm not sure at the moment. I know that, so we don't support those two claims at the moment.
Because with the groups is exactly the same problem as with the expiration of the token, that if you revoke a group from the user token, if it's carrying around information.
Then you're back to checking everything on the token, and you're kind of back to where you were before. All right, cool. Thank you very much. Do come and grab these. Honestly, I can't drink them all.